We're going to finish Module 1.3 looking at the design of an experiment. So we're talking about a well-designed experiment or experimental study, right? What we do with that or what happens with an experiment is that it's necessary, right, when we design it well, that it eliminates confounding, right? Eliminates any lurking variables, it eliminates potentially some doubt about how the influence of an explanatory variable, right, impacts the outcome of a response variable. There are some things to think about, components that we need to focus on with a well-designed experiment. One is called control, meaning that we look at the variables, we look at the groups, randomly select groups, and we control for those factors, right? I want to make sure the groups that I'm comparing, the one that gets the treatments, are similar, right, in many ways. So we control for that, and that's one way to help us really get what we call a cause and effect relationship, right? A causation. Another part of an experiment is the randomization, that people are randomly assigned to these groups. They're not voluntarily choosing, right? There's some randomization. And the third idea is what we call replication, which is the idea that we have large sample size, we have enough people to really kind of say the outcomes are we can feel secure with the outcomes, and the idea replication, replicate, to copy and duplicate, that if we did the experiment again that we would get similar results. And that's an important piece of an experiment, that if we did it again we should get similar results, right? Because we controlled and had randomization for that. We talk about controlling for factors, right? Can a new diet pill help people lose weight, right? Suppose we have two treatment groups, people who took the new diet pill each day and then a group who take a fake pill, right? We call that a placebo. We get that term, a placebo, with that, right, when we think about it. But what else would we want to control for, right? Not just like the groups get a pill. We would want to make sure maybe that they're the same gender, right? And it's this question, how do we ensure that it's actually the new pill? You need a control for other variables, gender, maybe weight, exercise level, age. These are all other variables that we would want to control for. And that's why it's kind of difficult to do a truly well-designed experiment. You have to control for a lot of variables and a lot of things. Now, this idea of control group, right? Control group here, a control group is a treatment group, right, in which the treatment should have no influence on the response variable, right? Let's look at this real quick, right? As we look at this here, when we're talking about these groups up here, right? You have the control group, the group that's not getting the treatment. It's the one that's kind of the one that, in this case, they got the fake pill in this one, right? But as you can kind of read the description, this is the specific control group. But the control group, again, is important because I want to be able to compare the control group with the experimental group, the one that got the treatment. And what we're hoping, right, for is that we can distinguish outcomes based on the groups. But we have to be aware of what's called the placebo effect, right? That sometimes people think just because they're getting something that they believe it, right? By giving participants in the group to a placebo treatment, right? We give them something where they think it is. But we know it's not, right? The drug. And so you can see here, group 2, a placebo treatment, a treatment which should have no effect on the response variable, but is given to participants who believe it may be effective. And then we can account for, right, any effects. And then again, to finish this, there are other types of studies. These are just some key terms, and we're not doing this in our class. This is an introductory class, but we have ideas of what's called blinding experiments, where the people don't know whether they're getting the drug or the fake drug, right? They're blind to what they're getting. That happens a lot in vaccine trials. A double-blind experiment is even the people doing the experiment don't know. Only one person above knows who's getting what, and they don't even know. That's a double blind. Not only do the participants not know, but the researchers don't know either. Key to all of this is what we call randomization and random assignment. that you randomly assign people to groups, and this helps us prevent what we call any bias from occurring, which allows us, right? It allows us to have similar groups. The treatment group and the control group would be similar, and that helps mitigate, right? Helps lessen any effects of lurking variables or confounding. And so again, keep that in mind. Hopefully you can get a better idea as you finish that. The last part, we talk about replication. Replication provides stronger evidence. If you can repeat the experiment, right, or you have nice large sample sizes, I feel confident with the results. Right, sample size has an impact on that. So large groups of people in the experiment and seeing the results gives you more confidence with that. And you may want to pause now and look at kind of, we would be in class, we would have this discussion about designing an experiment for lowering blood pressure, right? Consider 3 components of a well-designed experiment. And again, there's an outline here. Again, there's multiple ways that we could design an experiment for lowering blood pressure. It could be through drugs, exercise, diet, right? Those would be the treatments, randomly assigned groups. Could we replicate it, right, in a different scenario, different place, in one setting? What are we controlling for? What people eat, how much caffeine, exercise, do they smoke? There's so many things to think about. This is just one example here.